Welcome to a journey into the most mysterious places in the universe, regions so strange that the very laws of physics seem to falter and dissolve. These are territories where reality itself bends, where time stretches and warps beyond recognition, and where the rules that govern everything from falling apples to orbiting planets suddenly stop working. Picture this: places where a single teaspoon of matter would weigh as much as Mount Everest. Places where equations that normally describe the entire cosmos collapse into nonsense, leaving us staring into the unknown. These aren't scenes from science fiction. They are real phenomena scattered throughout the universe, waiting to be explored by minds curious enough to drift beyond the boundaries of ordinary understanding. Tonight, we're going to drift gently through these cosmic enigmas together. Whether you're settling into bed, curling up on a quiet evening, or simply letting your thoughts wander into the vast expanse of space, you've found the right place. This is where science meets mystery, where knowledge bumps up against the beautiful limits of human understanding. Before we begin our voyage into these strange territories, I'd love to know where in the world you're listening from. Are you gazing out at city lights from a bedroom window? Perhaps you're somewhere under a canopy of stars, feeling small beneath the infinite night sky. Drop a comment and let me know what time it is in your corner of the universe. There's something wonderfully connecting about knowing we're all scattered across this planet, yet here together, contemplating the same cosmic mysteries. Now, settle in comfortably. Take a deep breath. Let your shoulders relax. You don't need to remember every detail or take notes. Just let the words wash over you like gentle waves, carrying you deeper into contemplation of how beautifully strange our universe truly is. Deep in the constellation Cygnus, there exists something so fundamentally alien to our everyday experience that it defies imagination. It's a place where a region of space no larger than Manhattan contains more mass than the sun itself, compressed into a density so extreme that reality itself begins to unravel at the seams. This is a black hole, and at its center lies what physicists call a singularity, a point where the very concept of point loses all meaning. Here the curvature of space-time becomes infinite, and the equations that have served us so faithfully in describing the cosmos simply break down and surrender. But what does it really mean for physics to break down? Imagine you're reading a book, and suddenly in the middle of a sentence, the words transform into symbols you've never seen before, arranged in patterns that seem to defy the very idea of language. That's what happens to our mathematical descriptions of reality when they encounter a singularity. The numbers become infinite, the equations produce impossible results, and the laws that govern everything, from the dance of electrons to the motion of galaxies, reach their limits and admit defeat. Albert Einstein himself was deeply uncomfortable with these mathematical monsters his own theory had predicted. He spent years trying to prove they couldn't exist, that nature surely had some mechanism to prevent such extreme breakdowns in the fabric of space-time. Yet here we are, a century later, with telescopes that have photographed the shadows these invisible giants cast against the cosmic background. The most unsettling thing about black holes isn't just that they exist, it's that they represent a fundamental boundary of knowledge. Beyond the event horizon, that invisible point of no return, information itself might cease to follow the rules we understand. Some physicists suggest that anything falling past this boundary is lost forever, its information scattered and destroyed in a way that violates one of the most sacred principles of quantum mechanics. Other theorists propose something even stranger, that the three-dimensional reality we experience might be nothing more than a hologram, a projection from information encoded on the two-dimensional surface of the black hole's event horizon. In this interpretation, everything you see, touch, and experience might be the shadow of a deeper reality, written in a cosmic code we're only beginning to glimpse. As you consider this possibility, let yourself sit with the wonder of it. How might it feel to discover that the solid ground beneath your feet, the air you breathe, even your own thoughts and memories, are all expressions of information dancing on the surface of invisible spheres scattered throughout space? There's something both humbling and magnificent about such possibilities. If black holes are the universe's giants where physics breaks down through sheer gravitational brutality, then the quantum realm is its playground, where reality seems to abandon logic altogether through pure, inexplicable weirdness. At the smallest scales imaginable, smaller than atoms, smaller than the nuclei within atoms, we encounter something called the Planck length. This isn't just a very small distance, it's the distance at which the very concept of distance begins to lose meaning. Beyond this scale, approximately 1/quintillionth the width of a proton, the smooth fabric of space-time that Einstein described starts to look more like a foam, a chaotic froth of virtual particles popping in and out of existence in patterns that defy our deepest intuitions about how reality should behave. Here, in this quantum foam, causality itself becomes negotiable. Causes and effects can blur in unexpected ways, particles can exist in multiple places simultaneously, and the simple act of looking at something changes what you see in fundamental ways. It's as if reality, at its most basic level, is playing an elaborate game of hide and seek with itself. Consider the profound strangeness of quantum tunneling, where particles can pass through barriers that should be completely impenetrable. It's not that they find a way around or through these obstacles in any conventional sense. Rather, they simply appear on the other side, as if the barrier were merely a suggestion rather than a physical law. This isn't speculation or theory. It's the principle that makes the electronics in your phone possible, the process that powers the fusion reactions in the heart of stars. Yet when physicists try to apply the equations that work so beautifully at these microscopic scales to larger objects, to things like cats or chairs or human beings, the mathematics produces results so bizarre that they seem to defy the very notion of common sense. The famous thought experiment of Schrödinger's cat was designed to highlight this absurdity, to point out that quantum mechanics seems to suggest a cat could be simultaneously alive and dead until someone opens the box to look. The deeper we probe into the quantum realm, the more it seems to whisper that our everyday experience of a solid, predictable world might be nothing more than a statistical approximation, a kind of cosmic average taken over countless quantum events happening too quickly and at scales too small for our senses to detect. Perhaps nowhere in the universe is the breakdown of physics more complete than at the very moment and place where the universe itself began. This isn't just ancient history we're talking about, but the ultimate boundary condition of reality, a moment so fundamental that it shapes everything we see and experience today. Imagine winding the cosmic clock backward, watching galaxies draw closer together, stars compress and heat up, until finally we arrive at a moment approximately 13.8 billion years ago, when all of space, all of time, all of matter and energy were compressed into a region smaller than the period at the end of this sentence. This is what cosmologists call the Big Bang singularity, and it represents the most profound breakdown of physics we can conceive of. At this primordial moment, temperature and density were infinite, the curvature of space-time was infinite, and our equations don't just fail, they lose all meaning. It's not that we don't have enough computing power or clever enough mathematics to solve them, it's that the very concepts of temperature, density, and curvature lose their meaning when pushed to such extremes. But here's what makes this breakdown even more mysterious. Somehow, from this moment of infinite chaos, the universe we know emerged. In the first fraction of a second, space itself underwent a period of expansion, so rapid and dramatic that it outpaced even light itself. This process, called cosmic inflation, stretches our understanding to its limits and beyond. During inflation, regions of space that had been in contact, that had been able to exchange information and reach thermal equilibrium, were suddenly flung apart faster than any signal could travel between them. This creates what cosmologists call the horizon problem, a puzzle that hints at deeper mysteries about the nature of causality and information in the early universe. As you contemplate these cosmic origins, notice how the question of beginnings touches something deep within us. We are creatures who emerged from this ancient chaos, made of atoms forged in stellar furnaces that trace their lineage back to that first moment when physics itself was being born. In a very real sense, we are the universe becoming conscious of itself, matter organizing itself into patterns complex enough to contemplate its own origins. In the constellation Ara, approximately 700 light-years from Earth, there exists an object so dense that a sugar cube-sized piece of it would weigh as much as all of humanity combined. This is a neutron star, a cosmic graveyard where the familiar rules governing matter have been crushed out of existence by gravitational forces beyond imagination. When a massive star reaches the end of its life, when the nuclear furnace at its core finally exhausts its fuel, gravity wins a battle that has raged for millions of years. In less than a second, the star's core collapses from a region the size of Earth to a sphere no more than 20 kilometers across. The violence of this transformation is so extreme that it compresses atomic nuclei together, forcing protons and electrons to merge into neutrons, collapsing the star into something like a single, gigantic atomic nucleus. But even neutron stars pale in comparison to their more exotic cousins, objects that exist at the very edge of theoretical possibility. Some physicists speculate about the existence of strange matter, a form of matter so alien that it might convert any ordinary matter it touches into more of itself, spreading like a cosmic infection that could theoretically transform entire planets, stars, or even galaxies. This isn't science fiction speculation, but a serious theoretical possibility emerging from our understanding of quantum chromodynamics, the theory that describes the strong nuclear force. Under the extreme conditions found in the cores of the most massive neutron stars, quarks, the fundamental building blocks of protons and neutrons, might reorganize themselves into configurations that have never existed anywhere else in the universe since the first microseconds after the Big Bang. These strange quark stars, if they exist, would represent a completely new phase of matter, one where the boundaries between individual particles dissolve into something more fluid and collective. The equations that describe this strange matter suggest properties so bizarre that they challenge our basic assumptions about what matter can be and do. What's particularly fascinating is that these extreme states of matter might not be stable. Some theories suggest that strange matter could be the true ground state of the universe, meaning that all the ordinary matter we see around us, including our own bodies, might be living on borrowed time, existing in a metastable state that could theoretically collapse into something completely different. As we journey deeper into these mysterious regions where physics breaks down, we encounter something even more profound than exotic matter or warped space-time. We encounter the limits of knowledge itself, boundaries beyond which even our most sophisticated theories and instruments cannot venture. Consider the cosmic microwave background, that faint glow of radiation that fills all of space, carrying with it the oldest light in the universe. This ancient light, released when the universe was only 380,000 years old, represents the furthest back in time we can directly observe. Before this moment, the universe was opaque, a hot, dense plasma that trapped light like fog traps headlight beams. But what came before this moment of first light? What happened in those first 380,000 years? And more mysteriously, what occurred in the first fraction of a second when the universe was smaller than a proton and hotter than the core of the most massive stars? Here, we enter a realm where observation becomes impossible, where our theories collide with the fundamental limits of what can ever be known. Some interpretations suggest that asking what came before the Big Bang might be like asking what's north of the North Pole, a question that seems meaningful, but ultimately has no answer because it assumes a framework that doesn't apply. Time itself might have been created along with space and matter, making the very concept of before meaningless. This brings us face to face with one of the most humbling aspects of these mysterious places where physics breaks down. They remind us that the universe is under no obligation to be comprehensible to creatures like us, beings who evolved to hunt, gather, and navigate a world of medium-sized objects moving at moderate speeds. The fact that we can understand anything at all about black holes, quantum mechanics, or the Big Bang is perhaps the most miraculous mystery of all. Take a moment to sit with this thought. You're a pattern of atoms that was once scattered across space, forged in the nuclear furnaces of ancient stars, now organized into a form complex enough to contemplate the very processes that created you. There's something both cosmic and intimate about this realization, a reminder that the mysterious places where physics breaks down are not just distant curiosities, but part of the same reality that flows through every breath you take. Perhaps the most unsettling breakdown in physics isn't happening in some distant black hole or exotic neutron star, but right here, right now, in the space between the atoms of your body and in the vast emptiness between galaxies. This is the realm of dark energy, a mysterious force that makes up nearly 70% of everything that exists, yet behaves in ways that seem to violate our most basic intuitions about how energy should work. Under normal circumstances, energy follows predictable rules. When you stretch a rubber band, the elastic energy increases. When gas expands, its pressure decreases. But dark energy appears to work backwards, becoming stronger as space expands, as if the very act of creating more emptiness somehow generates more of this phantom force. Recent observations from the Dark Energy Spectroscopic Instrument have revealed something even more mysterious. Observations suggest that dark energy might not be constant, but evolving in ways still debated and controversial, in ways that could fundamentally alter the fate of the universe itself. If these tentative findings hold up, they point toward what physicists call the phantom regime, a state where dark energy becomes so dominant and so strange that it could eventually overcome not just gravity, but all the forces that hold atoms, molecules, and even space itself together. In this scenario, the universe would end not with a gentle fade into cold emptiness, but with a violent tearing apart of the very fabric of reality in what cosmologists call the Big Rip. The mathematics describing this phantom energy break down in ways that make physicists deeply uncomfortable. In Einstein's equations, this type of energy density creates paradoxes that seem to violate causality itself, allowing effects to precede their causes in ways that make mockery of our understanding of time and sequence. Yet here we are, embedded in a universe where this phantom force appears to be winning a cosmic tug-of-war against gravity, accelerating the expansion of space at an ever-increasing rate. Every second, more space is created between distant galaxies, and with it, apparently, more dark energy to drive even faster expansion. As you contemplate this invisible force that permeates every cubic centimetre of space around you, including the space between your molecules and even within your atoms, consider how it might feel to be swimming in an ocean of mystery so profound that it makes up most of reality itself. In our exploration of places where physics breaks down, we encounter perhaps the deepest puzzle of all. What happens to information when it encounters the extreme conditions we've been discussing? This question touches on something fundamental about the nature of reality itself, something that connects the quantum realm to black holes, to the very possibility of knowledge and memory. Every interaction in the universe, from the collision of two particles to the formation of a thought in your brain, involves the processing and transformation of information. Quantum mechanics tells us that information cannot be destroyed, only transformed from one form to another. This principle, called unitarity, is so fundamental that violating it would undermine the mathematical consistency of physics itself. But black holes seem to destroy information in ways that create what Stephen Hawking called the information paradox. When matter falls into a black hole, all the information about its quantum state seems to disappear forever behind the event horizon. And when the black hole eventually evaporates through Hawking radiation, that information appears to be lost permanently, creating a violation of unitarity that has puzzled physicists for decades. Recent theoretical work has proposed something called the quantum memory matrix hypothesis, though this remains highly speculative. This idea suggests that space-time itself might act as a kind of cosmic hard drive, encoding information about quantum interactions directly into the fabric of reality at scales so small they approach the Planck length. If this interpretation has any merit, and it's important to emphasize that no scientific consensus exists on this point, then every region of space might be keeping a perfect record of everything that has ever happened there. Your thoughts, your experiences, every quantum interaction in your body might be leaving permanent impressions in the structure of space-time itself. This is a deeply speculative idea, not a proven scientific fact, but it hints at connections between consciousness, memory, and the fundamental structure of reality that we're only beginning to explore. Some interpretations suggest that the breakdown of physics in extreme environments might not represent the destruction of information, but rather its transformation into forms we don't yet understand how to read. As our journey through these mysterious places continues, we'll discover that the boundaries where physics breaks down might not be walls blocking our understanding, but doorways opening onto even deeper mysteries about the nature of existence itself. The universe, it seems, has saved its most profound puzzles for regions where our normal rules simply don't apply, where reality becomes so strange that it challenges the very foundations of what it means to know anything at all. But before we venture further into these cosmic enigmas, I want to recommend a video that explores another profound mystery of our universe. 95% of the universe is missing, and no one knows why. It's a perfect complement to our journey tonight, delving into the dark matter and dark energy that make up the vast majority of everything that exists, yet remain almost completely invisible to us. You'll find it linked in the description below, and I think you'll find it the perfect continuation of tonight's contemplations. As we drift deeper into these cosmic territories where physics abandons its usual composure, we encounter perhaps the most philosophically troubling breakdown of all, places where the universe's deepest secrets might be laid bare, unprotected by the usual veils that keep reality's most disturbing truths hidden from view. Most black holes, those gravitational monsters we explored earlier, have the courtesy to hide their singularities behind event horizons, keeping their mathematical breakdowns politely out of sight. But some theoretical models suggest the existence of something far more unsettling: naked singularities, regions where space-time curvature becomes infinite without any protective boundary to shield the rest of the universe from the chaos within. Picture a cosmic wound that never heals, a tear in the fabric of reality that remains perpetually open, bleeding mathematical impossibilities into the space around it. At such a location, the future would become unpredictable in the most fundamental sense possible. Not because we lack sufficient data or computing power, but because the laws that connect cause to effect would simply cease to function. Roger Penrose, the mathematical physicist who shared the Nobel Prize for his work on black holes, proposed something called the cosmic censorship hypothesis, essentially the universe's modesty principle. It suggests that nature abhors naked singularities and will always find a way to clothe them in event horizons, keeping their embarrassing infinities hidden from polite cosmic society. Yet some solutions to Einstein's equations stubbornly refuse to cooperate with this cosmic dress code. Under certain conditions, during the collapse of rotating or electrically charged matter, the mathematics suggests that naked singularities could form, creating regions where anyone with a sufficiently powerful telescope could peer directly into the heart of a mathematical breakdown. The implications are staggering. If naked singularities exist, they could theoretically communicate with the rest of space-time, sending signals that carry within them the seeds of logical contradiction. information could emerge from these regions that violates the basic principles of causality, creating paradoxes that would collapse into contradictions that challenge even our boldest theories. As you contemplate this possibility, notice how it mirrors something deeply human about our relationship with mystery itself. There are some truths so profound, so potentially disturbing, that perhaps they're meant to remain hidden, protected by natural boundaries that preserve both cosmic and psychological stability. At the smallest scales of reality, far beyond anything you can see or even imagine, space itself begins to lose its smoothness. What appears empty and continuous at human scales becomes restless, frothing with constant fluctuations. This is the realm of quantum foam, where space-time trembles with jittery energy, and particles pop into and out of existence like fleeting sparks in the dark. Physicist John Wheeler coined the term to describe this microscopic chaos. Imagine looking closely at a calm ocean surface from far above. It appears flat and serene, but zoom in close enough and you'll see churning waves, ripples and splashes, constantly in motion. In the same way, what looks like a smooth fabric of space-time becomes a boiling, frothing quantum sea when observed at scales approaching the Planck length. Here, even the very concept of distance becomes uncertain. Points of space fluctuate so wildly that defining before and after, here and there, begins to break down. Wormholes might flicker into brief existence, connecting distant parts of the universe before vanishing again into nothingness. Virtual particles appear and disappear in an endless dance, contributing to what physicists call zero-point energy. The mathematics describing this seething foundation of reality collapse under the strain of infinities, and even our best theories, quantum mechanics and general relativity, become incompatible in this domain. To truly understand quantum foam, we would need a complete theory of quantum gravity, a framework that unites the physics of the very large with the physics of the very small. As you contemplate this, realize that the smoothness of space around you, the room, the air, the stars above, is an illusion of scale. Beneath it all lies a ceaseless restlessness, a trembling uncertainty woven into the very foundation of being. What feels solid, stable, and dependable ultimately rests upon a sea of froth, where existence itself flickers in and out of possibility. Every day, you experience one of the most profound mysteries of physics without even noticing it. You watch ice cubes melt in a glass of water, never the other way around. You grow older, never younger. You remember the past, not the future. These everyday experiences point toward the arrow of time, the one-way direction in which reality seems to unfold. From the standpoint of fundamental physics, the laws governing atoms and particles are time-symmetric. They don't care whether time flows forward or backward. The equations work just as well in either direction. Yet your lived experience, and indeed the history of the entire cosmos, depends upon a clear distinction between past and future. The mystery deepens when we consider entropy, the measure of disorder in a system. The second law of thermodynamics tells us that entropy always increases in closed systems, which gives time its direction. But why did the universe begin in a state of such incredibly low entropy, so ordered that it allowed stars, planets, life, and consciousness to emerge? This remains one of the deepest puzzles in cosmology. Some physicists suggest that the Big Bang was an extraordinarily improbable event, an initial condition so ordered that it allowed everything else to unfold. Others speculate that time itself might be emergent, a property that arises only in certain conditions, rather than being fundamental to the fabric of reality. Either way, the arrow of time remains one of the most beautiful paradoxes of physics. The laws that govern particles are reversible, yet the story of the universe is not. Take a moment to reflect on your own experience of time. Every heartbeat, every breath, every thought is part of this great unfolding, carried along by an arrow that never turns back. Time is not just something you pass through, it is the very rhythm by which the universe discovers itself. As we wander further into the strange lands where physics begins to dissolve into speculation, we encounter the possibility that our universe may not be the only one. The multiverse hypothesis suggests that our cosmos, vast as it seems, might be just one bubble in an endless froth of universes, each with its own laws, constants, and conditions. This idea emerges naturally from several different areas of physics. Inflationary cosmology suggests that the rapid expansion of space in the first fraction of a second after the Big Bang could have created countless separate regions, each effectively its own universe. String theory allows for an enormous number of possible vacuum states, each corresponding to a different way that the laws of physics might be configured. The multiverse, if it exists, could be infinite in scope. Somewhere out there might be another version of you, reading another version of these words, in a universe where conditions played out just slightly differently. In some universes, stars never formed. In others, life may have taken radically different paths. Yet the multiverse remains controversial, precisely because it may be untestable. By definition, other universes might be forever beyond our observational reach, sealed off by vast expanses of inflating space. Some critics argue that this makes the idea unscientific, a speculation without evidence. Others reply that if our best theories naturally predict a multiverse, then refusing to take it seriously would be a mistake. Either way, the multiverse represents a profound breakdown of our most basic assumption, that the universe we see is the universe there is. As you contemplate this possibility, notice how it expands your sense of identity. You're not just a product of one universe, but perhaps a reflection of a deeper reality where countless possibilities unfold. The multiverse, if real, suggests that existence itself is far more abundant and creative than we can possibly imagine. When you look up at the night sky, you are gazing across vast distances of space and billions of years of time. The light from the most distant galaxies has taken more than 13 billion years to reach your eyes. But beyond a certain point, no matter how powerful our telescopes become, we cannot see further. This limit is called the cosmic horizon. The cosmic horizon exists because the universe is expanding. Galaxies beyond a certain distance are receding from us faster than the speed of light, carried away by the expansion of space itself. Their light will never reach us, no matter how long we wait. Beyond that horizon lies a vast unknowable expanse, regions of the universe forever hidden from observation. This boundary is not a physical wall, but a limitation built into the structure of space-time itself. It represents the edge of our cosmic vision, the farthest we can ever hope to see. Yet what lies beyond it almost certainly exists. Galaxies, stars, perhaps even civilizations that will remain forever beyond our reach. Some cosmologists speculate that the universe might be infinite, stretching endlessly beyond the horizon. Others suggest it might wrap back on itself in higher dimensions, making the farthest regions closer than they appear. Either way, the cosmic horizon reminds us that our observational window is limited, and that the true scope of reality may be far larger than we can comprehend. As you reflect on this, notice how the horizon in physics mirrors horizons in consciousness. There are always limits to what you can know or perceive, boundaries beyond which lies the unknown. But rather than diminishing the mystery, these horizons give it depth, ensuring that wonder never runs dry. Imagine a time traveller who journeys into the past with a copy of Shakespeare's plays and hands them to the young bard. Shakespeare publishes them as his own, and centuries later, the time traveller acquires the same plays to take back in time. Who then actually wrote them? This is the bootstrap paradox, a breakdown in causality, where an object or piece of information seems to exist without origin, looping endlessly through time without ever being created. Physics encounters similar puzzles when we consider closed time-like curves, pathways through space-time that loop back on themselves, theoretically allowed in certain solutions to Einstein's equations. If a particle, or even a person, could travel such a curve, they might create causal loops that have no clear beginning or end. These paradoxes undermine our understanding of causation. They suggest that the linear chain of cause and effect we take for granted might break down under extreme conditions, creating situations where origins blur and history becomes self-sustaining. As you contemplate this, notice how it reflects something profound about the mysteries of consciousness and existence. Your awareness of this very moment seems to arise fresh and immediate, yet it depends on countless causes stretching back through time. At some level, every experience you have is a bootstrap paradox, a loop where cause and effect merge in the immediacy of now. For every particle we know, there exists an antiparticle, identical in mass but opposite in charge. When a particle and its antiparticle meet, they annihilate in a flash of energy, returning their mass to pure light. At first glance, this suggests a universe of perfect balance. Matter and antimatter should have been created in equal quantities at the Big Bang, cancelling each other out and leaving only radiation. Yet the universe we see is dominated by matter, with antimatter existing only in trace amounts. This asymmetry remains one of the deepest mysteries of cosmology. Why is there something rather than nothing? What tipped the scales in favour of matter over antimatter? Some experiments with particle accelerators suggest subtle violations of symmetry, processes where matter behaves ever so slightly differently than antimatter. These tiny imbalances, magnified across cosmic history, may have led to the universe we inhabit today. But the fundamental question remains unanswered. The breakdown of matter-antimatter symmetry represents not just a technical puzzle, but a profound clue that the universe is not perfectly balanced. Somewhere, deep in the equations of physics, lies a preference for being rather than non-being. This asymmetry is the reason you exist. The reason there are stars to shine, planets to orbit them, and consciousness to wonder at it all. What if everything you see, feel, and experience is not the fundamental reality, but the output of some vast computation? The simulation hypothesis suggests that our universe might be a kind of cosmic program, running on unimaginable hardware in some higher reality. This idea, once relegated to science fiction, has gained serious consideration among philosophers and physicists. The reasoning is unsettlingly simple. If advanced civilizations ever develop the ability to run simulations indistinguishable from reality, and if they run even a fraction of the simulations they could, then simulated realities would vastly outnumber base realities. Statistically, it's more likely we're in one of the simulations. Evidence remains elusive, but some physicists speculate that certain features of the universe, such as the quantization of space and time at the Planck scale, could be interpreted as signs of an underlying computational structure, like the pixels of a cosmic screen. Others suggest that the apparent fine-tuning of physical constants could be explained if our universe is a designed simulation, calibrated to support complexity and consciousness. Whether or not the simulation hypothesis is true, its real significance lies in how it reframes our sense of reality. If the universe is computation, then physics becomes computer science, and consciousness becomes the ultimate interface between code and meaning. Yet even if we are in a simulation, the wonder remains real. The beauty of a sunset, the ache of love, the mystery of existence, these experiences matter, regardless of the substrate that generates them. One of the strangest discoveries in modern physics is that the act of measurement seems to affect the system being measured. In the famous double-slit experiment, particles behave like waves when unobserved, spreading out in interference patterns. But when we observe which slit they pass through, they behave like particles, as if the very act of observation collapses the wave of possibilities into a single outcome. This raises profound questions. What does it mean to observe? Does consciousness itself play a role in creating reality, Or is observation simply any interaction with the environment? Some interpretations of quantum mechanics, like the Copenhagen interpretation, suggest that measurement collapses the wave function. Others, like the many worlds interpretation, suggest that every possible outcome occurs in parallel universes, and observation simply reveals the branch we inhabit. Either way, the breakdown here is extraordinary. Reality does not exist as a definite set of facts until interaction forces it to choose. As you reflect on this, notice how your own awareness participates in this mystery. Every perception, every thought, every decision collapses countless possibilities into the actuality of your lived experience. In this way, consciousness and cosmos dance together at the boundary where potential becomes real. Entropy is often described as disorder, but it's more subtle than that. It's about the number of ways a system can be arranged, the measure of possibility rather than structure. A deck of cards in perfect order has low entropy, while the same deck shuffled has high entropy, not because the cards are less structured, but because there are far more possible shuffled states than ordered ones. The second law of thermodynamics tells us that entropy always increases in closed systems. This gives rise to the irreversible flow of time, the gradual heat death of the universe, the one-way direction in which order gives way to chaos. But here's the enigma. If entropy must always increase, how did the universe begin in such an exquisitely low entropy state? This is one of the deepest puzzles in cosmology. The Big Bang should have created a high entropy mess, yet instead it created the conditions for stars, planets, life, and consciousness. Some physicists suggest that gravity itself complicates our intuition about entropy, creating pockets of increasing order, galaxies, stars, and planets, while the overall entropy of the universe still rises. Others propose that our universe might be part of a larger multiverse, where low entropy beginnings happen regularly. Whatever the explanation, the entropy enigma represents a breakdown in our understanding of cosmic origins. We know that entropy shapes the flow of time and the fate of the cosmos, yet we cannot explain why the universe began with such improbable order. As you reflect on this, notice how entropy touches your own life. Memory fades, bodies age, structures decay. Yet within this universal drift toward disorder, moments of beauty, meaning, and creativity still emerge, testaments to the delicate balance that makes conscious experience possible. Perhaps the most embarrassing breakdown in modern physics concerns the vacuum, the energy of empty space. Quantum field theory predicts that even nothing seethes with energy, virtual particles flickering in and out of existence. When physicists try to calculate how much energy this quantum vacuum should contain, they arrive at a number that is 120 orders of magnitude larger than what we actually observe. To put that in perspective, it's like predicting that an elephant weighs more than the entire universe. This mismatch between theory and observation has been called the worst prediction in the history of physics. It's not a minor discrepancy, but a profound failure that suggests something is deeply wrong with our understanding of quantum mechanics, gravity, or both. Some physicists speculate that dark energy, the mysterious force accelerating the expansion of the universe, might be related to vacuum energy, but in a way we don't yet understand. Others propose that some hidden principle cancels out most of the vacuum's energy, leaving only a tiny residue. Whatever the resolution, the vacuum catastrophe reminds us that even our most successful theories can collapse when pushed to their limits. The equations that describe the subatomic world with exquisite accuracy fail spectacularly when applied to the emptiness between the stars. As you contemplate this, notice how the concept of nothing dissolves under scrutiny. What seems like empty space is actually a seething ocean of potential, a reminder that reality is far stranger than our everyday experience suggests. In the strange world of quantum mechanics, particles exist in multiple states at once, here and there, up and down, alive and dead, until a measurement forces them into a definite outcome. This is called superposition, and it works beautifully in equations and experiments. But here's the problem. Every measurement transforms multiple quantum possibilities into one definite classical outcome. No one knows exactly how or why this collapse occurs. Is it the act of conscious observation that forces a choice? Is it interaction with the environment, a process called decoherence, that makes one outcome real? Or is collapse just an illusion, with all possibilities playing out in parallel universes we cannot see? The measurement problem is not a minor technical detail, but a profound mystery at the heart of reality. It challenges the boundary between the quantum and classical worlds, between the possible and the actual, between mathematics and experience. As you reflect on this, notice how your own awareness mirrors this mystery. At every moment, countless possibilities of thought, feeling, and action collapse into the actuality of your lived experience. Like the quantum world, consciousness is a dance between potential and realization. Across cultures and traditions, myths speak of the universe beginning as a cosmic egg, a symbol of potential waiting to hatch into form. Strangely, modern cosmology offers its own version of this ancient image. At the moment of the Big Bang, all of space, time, matter, and energy were compressed into an unimaginably small, dense state. From this seed, the cosmos expanded, giving birth to galaxies, stars, planets, and consciousness. But what came before the cosmic egg? Was it truly the beginning, or just one phase in an eternal cycle of expansion and collapse? Some theories of quantum cosmology suggest that our universe may have bounced from a previous one, born from the collapse of an earlier cosmos. Others propose that universes are constantly budding off from a larger multiverse, each a new egg hatching into its own reality. Here physics meets mystery. Our equations can trace the universe back to the first fraction of a second, but beyond that, they dissolve. We cannot say with certainty whether the cosmic egg was unique or one of countless others. What we do know is this: the universe we inhabit carries within it the potential for endless creation, a story still unfolding in every star, every atom, and every conscious thought. As we push toward the ultimate limits of physics, we encounter the Planck scale, the unimaginably small realm where our current theories simply cease to apply. At distances of about 10 to the power of negative 35 meters and times of about 10 to the power of negative 43 seconds, space and time themselves stop behaving like smooth, continuous fabrics and begin to dissolve into something far stranger. At this scale, quantum fluctuations of space-time become so violent that our familiar concepts of geometry, distance, and duration lose all meaning. Trying to measure anything here is like trying to measure the surface of the ocean during a hurricane. The very act of observation is swallowed by chaos. The Planck wall represents the boundary where our two greatest theories, general relativity and quantum mechanics, contradict each other so violently that neither can be trusted. Relativity predicts smooth space-time curvatures, while quantum theory predicts jittery fluctuations. Their clash creates infinities that no calculation can tame. Some physicists believe that string theory or loop quantum gravity may provide the tools to see beyond this wall. Others suggest that our very notions of space and time may be emergent, like temperature or pressure, meaningful only at larger scales, but dissolving into something more fundamental at the smallest. As you contemplate the Planck wall, notice how it mirrors the boundaries of your own awareness. Just as there are limits to what physics can describe, there are limits to what consciousness can perceive. Yet both frontiers invite curiosity, reminding us that the deepest mysteries lie precisely where our current frameworks break down. As strange as it sounds, one of the most profound breakdowns in physics may be happening not in the stars, but within your own awareness. We can describe brain activity in terms of neurons, synapses, and electrochemical patterns. But how does this physical activity give rise to the felt sense of being conscious? The vivid, first-person experience of seeing, feeling, and knowing. This is what philosopher David Chalmers calls the hard problem of consciousness. Why should any arrangement of matter produce inner experience at all? Why is there something it is like to be you, reading these words rather than just blind computation without awareness? Neuroscience can map correlations between brain states and experiences, but correlation is not explanation. The leap from matter to mind, from objective process to subjective feeling, remains utterly mysterious. Some speculative ideas suggest that consciousness may involve quantum processes where coherence and entanglement play roles in brain activity. Others propose that awareness is not something the brain produces, but something more fundamental, an intrinsic aspect of reality, as basic as mass or charge. Wherever the truth lies, the consciousness horizon represents a boundary as mysterious as any black hole or quantum singularity. It reminds us that the most profound enigmas are not just out there in the cosmos, but here in the immediacy of our own lived experience. For centuries, science seemed to promise a perfectly predictable universe. If you knew the position and velocity of every particle, then in principle, you could calculate the entire future and reconstruct the entire past. This vision of clockwork determinism, championed by Laplace, painted the cosmos as a vast mechanical machine. But quantum mechanics shattered that vision. At the subatomic scale, outcomes are not determined but probabilistic. You can predict the likelihood of a particle appearing here or there, but not its exact position. Reality contains genuine randomness, irreducible uncertainty woven into its fabric. Even at larger scales, complexity creates unpredictability. Chaos theory shows how small differences in initial conditions can snowball into massive divergences, as in the famous butterfly effect. A butterfly flapping its wings in Brazil may alter the course of a hurricane months later. This doesn't mean the universe is lawless. It means the laws of physics govern possibilities, not certainties. Reality unfolds as a blend of necessity and chance, structure and spontaneity. The death of determinism is not the end of science, but the beginning of a deeper understanding of a cosmos that is creative, open-ended, and full of surprises. As you reflect on this, notice how it resonates with your own life. The future is not a script already written, but a field of possibilities shaped by choices, chance, and mystery. In the deepest territories of our exploration, we encounter a breakdown so intimate that it touches every moment of your conscious experience. This isn't happening in some distant galaxy or exotic laboratory, but right here, right now, in the mysterious process by which unconscious neural activity somehow gives rise to the felt sense of being you. The hard problem of consciousness represents perhaps the most profound breakdown in reductive materialism. How does the electrochemical firing of neurons, processes that should be entirely mechanical and unconscious, give rise to the subjective experience of reading these words, of understanding their meaning, of feeling wonder at the mysteries they describe? This breakdown becomes even more intriguing when we consider recent research into what some scientists call the binding problem. Your brain processes color in one region, motion in another, sound in yet another area. Yet somehow, all these separate streams of information are woven into a seamless tapestry of conscious experience. No one knows exactly how this integration occurs or why it should feel like anything from the inside. Some interpretations suggest, though this remains highly speculative and controversial, that consciousness might involve quantum processes operating at scales where classical physics begins to break down. Not that your thoughts directly control quantum events, but that the emergence of conscious experience might depend on quantum coherence effects in biological systems. This is a speculative idea, not a proven scientific fact, but it points toward possible connections between the mystery of consciousness and the strange behaviors we observe in quantum mechanics. Perhaps both represent different aspects of reality's fundamental creativity, its capacity to generate genuinely novel phenomena from simpler components. As you sit with your own immediate experience of awareness, notice the profound mystery of this very moment. Somehow patterns of matter have organized themselves into forms capable of self-reflection, capable of experiencing wonder at their own existence. You are the universe temporarily folded into a configuration that allows it to know itself. Perhaps the most beautiful breakdown in our understanding occurs when we recognize that information itself might be more fundamental than the matter and energy we can touch and measure. This perspective, emerging from decades of work in quantum mechanics, black hole physics, and computational theory, suggests that reality might be better understood as patterns of information processing rather than as collections of solid objects moving through empty space. Consider the holographic principle we explored earlier, but now from this informational perspective. If all the information in any volume of space can be encoded on its boundary, then perhaps space itself is less like a container and more like a vast computational matrix, processing information in ways that create the illusion of three-dimensional reality. This breakdown of the matter-information distinction becomes particularly profound when we consider biological systems. Your DNA contains information, but that information only becomes meaningful when it's read and interpreted by cellular machinery. Your memories exist as patterns of neural connectivity, but they only become conscious experiences when they're accessed and integrated with present moment awareness. The boundary between information and experience, between data and consciousness, represents a frontier where physics meets philosophy in the most intimate way. Every thought you think, every emotion you feel, every decision you make involves the processing and transformation of information in ways that remain largely mysterious to science. Some theoretical frameworks suggest, though this remains unproven and highly speculative, that consciousness might be understood as a fundamental feature of information processing systems. Not that computers are conscious in the way you are, but that the capacity for subjective experience might emerge naturally from certain types of integrated information. As you contemplate the informational nature of your own experience, notice how even this very process involves the mysterious transformation of abstract symbols into meaningful understanding. The words you're reading are just patterns of light and shadow, yet somehow they evoke images, ideas, and feelings in your mind. This everyday miracle of meaning-making might offer clues to the deepest workings of reality itself. As we near the completion of our journey through cosmic territories where physics breaks down, we encounter what might be the most hopeful breakdown of all. The way complex systems can exhibit properties and behaviors that genuinely transcend the sum of their individual components. This isn't just about complicated interactions between simple parts, but about the emergence of entirely new levels of reality that cannot be reduced to their underlying constituents. Consider how wetness emerges from H2O molecules that are not themselves wet, how life emerges from chemical processes that are not themselves alive, how consciousness emerges from neural activity that is not itself conscious. At each level of organization, reality exhibits what philosophers call emergent properties, genuinely novel qualities that cannot be predicted or explained by examining the components in isolation. This emergence hierarchy extends throughout the universe, from the quantum realm where particles exhibit collective behaviors that transcend individual properties, to cosmic scales where galaxy clusters form structures that follow rules different from those governing individual stars. At each transition point, the reductive approach of traditional physics breaks down, unable to capture the full richness of what emerges from collective organization. The mathematical frameworks we use to describe emergent phenomena often involve phase transitions, critical points where small changes in underlying parameters can trigger dramatic reorganizations of entire systems. Near these critical points, traditional equations break down, producing infinite correlations and behaviors that seem to transcend the rules that created them. Yet these breakdowns often herald the birth of new forms of order and beauty: crystalline structures, spiral galaxies, the branching patterns of rivers and lightning, the intricate architectures of living cells, all emerge from simple rules operating at boundaries where predictable physics gives way to creative novelty. As you reflect on your own place in this hierarchy of emergence, consider how you represent perhaps the most remarkable example of all: matter organized into patterns complex enough to contemplate the very processes that created them. Your capacity for wonder, for understanding, for connection with something larger than yourself emerges from neural processes that individually have none of these qualities. Take a gentle breath and feel the remarkable nature of this emergence happening within you right now. Your lungs extract oxygen from air, your heart pumps blood through vessels, your brain processes information from your senses. Yet from all these mechanical processes emerges the irreducible experience of being you, aware and alive in this moment. In our continuing exploration of physics' most profound breakdowns, we encounter the dissolution of one of our most cherished assumptions: the idea that objects in the universe exist as separate, independent entities interacting across empty space. Modern physics reveals a reality far more interconnected and interdependent than our everyday experience suggests. Quantum entanglement, Einstein's famous spooky action at a distance, demonstrates that particles can remain connected in ways that transcend the classical boundaries of space and time. When two particles become entangled, measuring one instantly affects the other, regardless of the distance between them. This isn't just a curious laboratory phenomenon, but appears to be a fundamental feature of reality at all scales. Recent research has revealed that this quantum interconnectedness extends far beyond individual particle pairs. Quantum field theory shows us that all particles are really excitations in underlying fields that permeate all of space. The electron in your body and the electron in a distant star are both ripples in the same universal electron field, connected in ways that transcend classical notions of separation. This field-based view of reality suggests that the boundaries we perceive between objects might be more like waves on an ocean, apparent separations that mask an underlying unity. The atoms in your hand, the air you breathe, the light from distant galaxies, all emerge from quantum fields that fill every point in space, creating a web of connection that binds the universe into a single, integrated whole. As you sit quietly with this idea, notice how it might resonate with certain aspects of conscious experience. In moments of deep contemplation or meditation, the sense of being a separate self sometimes softens, revealing glimpses of connection with something larger and more inclusive. While we must be careful not to conflate subjective experiences with objective physical phenomena, there's something beautiful about recognizing that both point toward the interconnected nature of reality. The breakdown of classical separateness extends to the relationship between consciousness and the physical world. Rather than being isolated observers peering at an external reality, we might be more like whirlpools in a stream, temporary patterns of organization within the same fundamental process that creates galaxies, stars, and the quantum vacuum itself. As we venture into the deepest philosophical territories where physics meets questions of meaning and purpose, we encounter breakdowns that touch the very foundations of how we understand our place in the cosmic story. These aren't just abstract theoretical puzzles, but questions that go to the heart of why anything exists at all, and why conscious beings like you have emerged to contemplate these mysteries. The fine-tuning of cosmic parameters we explored earlier takes on new significance when viewed from this perspective. The incredible precision required for stars to form, for chemistry to be possible, for complexity to emerge from simplicity, suggests that the universe might be structured in ways that make the emergence of consciousness not just possible, but perhaps inevitable. Some interpretations suggest though this remains highly speculative and controversial, that the universe might exhibit what we could call a bias toward complexity, a tendency to generate increasing levels of organization and awareness over cosmic time. This isn't a claim about divine design or supernatural intervention, but recognition that the laws of physics seem remarkably conducive to the emergence of patterns that can understand and appreciate the very laws that created them. This perspective doesn't require abandoning scientific rigor or embracing mystical thinking. Rather, it invites us to consider whether the capacity for meaning-making, for wonder, for conscious reflection on existence itself might be as fundamental a feature of reality as mass, charge, or the speed of light. The breakdown occurs when we try to separate subjective physical processes from subjective meaning and value. Traditional science assumes that the universe is fundamentally meaningless, with consciousness and purpose being late-arriving accidents in an otherwise mechanical cosmos. But what if meaning and purpose are woven into the fabric of reality from the beginning, expressed through the same physical laws that govern stars and galaxies? As you contemplate your own experience of finding meaning in existence, of feeling wonder at cosmic mysteries, of sensing connection with something larger than yourself, consider the possibility that these aren't just biological accidents, but expressions of the universe's fundamental creative principles. You are the cosmos becoming conscious of itself, organized into patterns capable of appreciation, gratitude, and awe. In this penultimate exploration of cosmic territories where physics breaks down, we encounter perhaps the most mind-bending phenomenon of all: the way consciousness creates recursive loops, where questions generate new questions, where understanding deepens mystery rather than eliminating it, and where every answer opens doorways to even more profound unknowns. Consider the strange loop of consciousness, studying consciousness. You're using your mind to investigate the nature of mind, employing the very phenomenon you're trying to understand as the tool of investigation. It's like trying to see your own eyes without a mirror, or attempting to bite your own teeth. The recursive nature of this inquiry creates logical loops that would make even the most sophisticated computer overload. This recursive quality extends to physics itself. Every time we probe deeper into the nature of reality, we discover new layers of mystery. Atoms were supposed to be indivisible until we found they contained nuclei and electrons. Nuclei were supposed to be simple until we discovered quarks and gluons. Quarks were supposed to be fundamental until string theory suggested they might be vibrations in higher dimensional spaces. Each answer generates new questions in an endless, recursive cascade of curiosity and discovery. It's as if the universe reveals just enough to keep us investigating while always maintaining deeper mysteries that call us forward into greater understanding and wonder. The breakdown occurs when we try to find a final, ultimate explanation that doesn't itself require explanation. Every why leads to another why in an infinite regress that seems to challenge our desire for complete understanding. Yet this isn't a failure of science, but perhaps its greatest success: the recognition that reality is inexhaustibly mysterious, always offering new depths for conscious beings to explore. As you sit with these recursive mysteries, notice how your own consciousness exhibits this same self-referential quality. You can be aware of being aware, can think about thinking, can feel curious about the nature of curiosity itself. This reflexive capacity might not be a flaw in the system of consciousness, but its most essential feature: the quality that allows the universe to know and appreciate itself through minds like yours. Take a moment to appreciate the beautiful strangeness of this situation. You exist as a temporary pattern in the cosmic web, complex enough to contemplate the very processes that created you, curious enough to ask questions about the nature of questioning itself, conscious enough to wonder about consciousness. In this recursive loop of inquiry, the universe discovers new ways to surprise itself with the depths of its own creative possibilities. As we approach what might seem like the conclusion of our journey through cosmic territories where physics breaks down, we discover that endings themselves represent another beautiful breakdown in our linear way of understanding. In the deepest sense, there are no final conclusions in the exploration of cosmic mysteries, only temporary resting places in an infinite landscape of wonder and discovery. Every question we've explored tonight, from black hole singularities to quantum consciousness, from the nature of time to the meaning of existence, itself opens onto vast territories of further investigation. Like fractals that reveal infinite detail at every level of magnification, reality appears to be structured in ways that guarantee endless fascination for any mind curious enough to keep exploring. This infinite quality isn't just a feature of cosmic mysteries, but seems to be built into the very nature of conscious inquiry. The capacity to ask questions, to wonder, to seek understanding appears to be inexhaustible. No matter how much we learn about the universe, there's always more to discover, always deeper layers of mystery calling us forward into greater appreciation and awe. Perhaps this is the most profound breakdown of all, the dissolution of the boundary between knower and known, between the investigator and the investigated, between consciousness and cosmos. As we've seen throughout our journey, you are not separate from the mysteries we've been exploring, but intimately woven into the same reality that creates black holes and quantum fields, cosmic expansion and emergent complexity. In recognizing this deep interconnection, the very act of cosmic inquiry becomes a form of cosmic self-discovery. When you experience wonder at the universe's mysteries, the cosmos is experiencing wonder at itself. When you probe the boundaries where physics breaks down, reality is exploring its own deepest creative possibilities. As you prepare to transition from this contemplative journey back into the rhythms of daily life, carry with you not just knowledge about distant phenomena, but a renewed appreciation for the miracle of your own awareness. Every breath involves quantum processes. Every heartbeat participates in the same electromagnetic forces that govern stars and galaxies. Every moment of consciousness represents the universe temporarily organized into a pattern capable of self-reflection and wonder. The breakdowns in physics we've explored remind us that reality is far more creative, mysterious, and beautiful than our everyday assumptions suggest. But they also point towards something hopeful, a universe that seems to be constantly transcending its own limitations, constantly surprising itself with new forms of order, complexity, and meaning. Rest well tonight, knowing that you are not just an observer of cosmic mysteries, but an active participant in the universe's ongoing story of self-discovery. The questions we've contemplated together will continue unfolding in your thoughts and dreams, opening new pathways of wonder and understanding that extend far beyond any single exploration. In the deepest recesses of theoretical physics, there exists a profound mystery that touches every atom in your body, every star in the sky, and every moment of your existence. It's called spontaneous symmetry breaking, and it represents one of the most elegant failures in the universe's attempt to maintain perfect balance. Picture a perfectly spherical hill with a ball balanced precisely at its peak. This represents perfect symmetry. The ball could roll down in any direction with equal probability. Yet the slightest disturbance, even a quantum fluctuation smaller than the imagination can grasp, will cause the ball to choose one particular path down the slope. The perfect symmetry shatters spontaneously, not because of any external force, but because reality itself seems to prefer specific choices over perfect indecision. This isn't merely a thought experiment. It's the fundamental mechanism that created the very particles that compose your thoughts as you contemplate these words. In the first moments after the Big Bang, the universe existed in a state of perfect symmetry where all forces were unified into a single, elegant whole. But as the cosmos cooled, this symmetry couldn't maintain itself. It broke spontaneously, fragmenting into the four fundamental forces we observe today: gravity, electromagnetism, and the strong and weak nuclear forces. Each breaking was a creative act, a moment where the universe chose complexity over simplicity, diversity over uniformity. The Higgs field, that invisible ocean of energy that permeates all space and gives mass to particles, represents the residue of one such symmetry breaking. Before this breaking occurred, particles like electrons and quarks would have been massless, racing through space at light speed, unable to bind together into atoms. Take a gentle breath and consider how this cosmic creativity flows through your very existence. The calcium in your bones, the iron in your blood, the carbon chains that encode your memories, all exist because the universe repeatedly chose to break its own perfect symmetries, trading mathematical elegance for the rich complexity that makes consciousness possible. But here's where the breakdown becomes truly mysterious. The equations that describe symmetry breaking often produce what mathematicians call multiple valid outcomes, different possibilities equally supported by the physics. The universe faces genuine choices at these critical moments, and somehow it always chooses. The mechanism by which these choices are made remains one of the deepest unsolved problems in theoretical physics. As we venture further into territories where traditional physics dissolves into something more fundamental, we encounter the startling possibility that the universe itself might be engaged in a vast computation, processing information at scales and speeds that dwarf our most powerful supercomputers. This digital physics hypothesis suggests that reality, at its most basic level, might be less like a machine and more like a cosmic calculation unfolding across space and time. Consider the quantum mechanical processes happening within every atom of your body right now. Each electron orbiting each nucleus exists in a state of quantum superposition, simultaneously exploring all possible energy levels until the moment when interaction with its environment forces a specific outcome. These quantum calculations are happening trillions of times per second throughout your body, processing information about position, momentum, spin, and countless other quantum properties. From this perspective, the breakdown of physics in extreme environments takes on new meaning. Perhaps what we interpret as mathematical infinities and impossible results are actually limits of computational capacity, moments when the universe's information processing reaches its threshold. The Planck scale, that impossibly small distance where space and time themselves become quantized, might represent the universe's fundamental pixel size, the smallest unit of cosmic computation. Recent work in quantum information theory has revealed deep connections between physical processes and computational operations. Quantum entanglement can be understood as a form of distributed computing, where information is processed non-locally across vast distances. Black holes might be the ultimate quantum computers, processing information at the theoretical maximum rate allowed by physics, transforming matter and energy into pure computational substrate. As you sit quietly with these ideas, notice how they might resonate with your own experience of consciousness as an information processing system. Your brain performs roughly 10 quadrillion calculations per second. Yet somehow, from this vast computational activity emerges the unified, coherent experience of being you. Perhaps consciousness and cosmos operate according to similar computational principles, both representing different scales of the same fundamental information processing reality. This computational view doesn't diminish the mystery of existence, but deepens it. If the universe is indeed a vast calculation, what is the question it's trying to solve? What cosmic algorithm is unfolding through the evolution of galaxies, the emergence of life, and the development of conscious observers capable of contemplating these very questions? In our continuing exploration of cosmic boundaries where physics meets philosophy, we encounter one of the most profound breakdowns in traditional scientific thinking: the recognition that the very existence of conscious observers might be woven into the fundamental structure of physical law itself. This isn't a claim about supernatural design, but rather an acknowledgement that the universe seems to be structured in ways that make observation and understanding not just possible, but perhaps inevitable. The anthropic principle, in its various forms, points toward a remarkable feature of cosmic evolution. The emergence of complexity appears to be built into the fabric of reality from the very beginning. The same physical laws that govern the formation of galaxies also permit the emergence of chemistry, biology, and eventually consciousness. It's as if the universe contains within itself the seeds of its own self-awareness. Consider the extraordinary precision required for this cosmic unfolding. If the expansion rate of the early universe had been slightly different, matter would never have condensed into stars. If the nuclear forces were marginally stronger or weaker, the heavy elements necessary for life would never have formed. If the electromagnetic force had been only slightly different in strength, chemistry as we know it would be impossible. Yet here we are, patterns of organized matter complex enough to contemplate the very forces that created us. You exist as living proof that the universe has developed the capacity to know itself through conscious observers embedded within its own structure. This represents a kind of cosmic recursion where reality becomes self-referential in the most profound sense possible. Some interpretations suggest, though this remains highly speculative, that consciousness might play a more fundamental role in physics than classical materialist thinking assumes. Not that thoughts directly control quantum events, but that the capacity for observation and measurement might be as basic to reality as mass, energy, or electric charge. This perspective doesn't require abandoning scientific rigor, but it does invite us to consider whether the emergence of conscious observers represents a fundamental feature of cosmic evolution rather than an unlikely accident. Perhaps the universe evolves toward greater complexity, organization, and self-awareness through the same physical processes that create stars, planets, and the quantum vacuum itself. As you reflect on your own role as a conscious observer in this cosmic system, take a moment to appreciate the remarkable nature of this recursive relationship. You are the universe becoming aware of itself, matter organized into patterns capable of wonder, curiosity, and the capacity to ask why anything exists at all. Perhaps the most beautiful aspect of our journey through regions where physics breaks down is the recognition that these apparent limitations often reveal themselves to be not walls, but doorways, not endings, but invitations to explore even deeper mysteries. Every boundary we encounter in the physical world seems to open onto new territories of understanding and wonder. Consider the speed of light, that cosmic speed limit that prevents information from traveling faster than roughly 300 million meters per second. This limitation might seem restrictive, but it's actually what makes causality possible, what prevents effects from preceding their causes, and what maintains the logical structure that allows conscious beings to exist and make sense of their experience. Yet even this fundamental limit becomes negotiable in certain circumstances. During cosmic inflation, space itself expanded faster than light, carrying distant regions beyond each other's causal horizons. Quantum entanglement allows instantaneous correlations across arbitrary distances, though in ways that preserve causality by preventing faster-than-light communication. The uncertainty principle represents another apparent limitation that reveals itself to be a creative feature. The inability to simultaneously measure position and momentum with perfect precision isn't a failure of our instruments, but a fundamental property of reality that prevents the universe from becoming completely deterministic and predictable. These quantum limitations create the breathing room necessary for novelty to emerge, for systems to explore new possibilities, for consciousness to make genuine choices rather than simply following predetermined paths. The fuzziness at the heart of quantum mechanics might be what allows the universe to remain creative and surprising rather than becoming locked into rigid, mechanical patterns. Take a gentle breath and notice how these physical boundaries might mirror certain aspects of conscious experience. The limits of what you can know or predict don't diminish the richness of existence, but rather create space for wonder, growth, and the ongoing adventure of discovery. As we approach the natural conclusion of our cosmic journey, remember that every ending in science and philosophy becomes a new beginning. The mysteries we've explored together tonight will continue unfolding in ways that extend far beyond any single contemplation, opening new pathways of understanding that stretch toward infinite horizons of wonder and discovery. As our gentle voyage through the most mysterious places in the universe draws toward its natural conclusion, we find ourselves arriving not at a destination, but at a deeper appreciation for the endless nature of cosmic inquiry itself. The territories we've explored together, from quantum foam to consciousness, from symmetry breaking to computational cosmos, all point toward a remarkable truth. The universe appears to be structured as an infinite mystery, always offering new depths for curious minds to explore. This isn't a failure of human understanding, but perhaps the most beautiful feature of reality. Each answer we discover opens doorways to new questions. Each solution reveals new problems to contemplate. Each moment of clarity illuminates vast territories of unknown waiting to be explored. The breakdown of physics in extreme environments reminds us that the cosmos is far more creative and mysterious than our everyday assumptions suggest. So, throughout our journey tonight, we've encountered the profound interconnectedness that weaves together all levels of existence, the quantum fields that permeate empty space, the symmetry breakings that create particle masses, the computational processes that might underlie physical law itself, the anthropic fine-tuning that makes consciousness possible. All these phenomena point toward a universe that is not a collection of separate objects, but a unified whole expressing itself through countless forms. You are not separate from these cosmic mysteries, but intimately woven into the same reality that creates black holes and quantum entanglements, cosmic expansion, and emergent complexity. Every breath you take involves the same electromagnetic forces that govern stellar fusion. Every thought that forms in your mind emerges from quantum processes operating at the boundary where classical physics breaks down. This recognition doesn't diminish your individual significance, but reveals your deep participation in the universe's ongoing story of self-discovery. Through your curiosity, your wonder, your capacity for understanding and appreciation, the cosmos develops new ways to know and value itself. As you prepare to transition from this contemplative space back into the rhythms of daily life, carry with you not just knowledge about distant phenomena, but a renewed sense of connection with the creative processes that flow through every moment of existence. The mysteries we've explored together continue their eternal dance in the quiet spaces between sleeping and waking, between knowing and wondering, between self and cosmos. Rest well tonight, knowing that you participate in something far grander and more beautiful than our minds can fully comprehend. The universe dreams through conscious beings like you, and in your wonder at its deepest mysteries, it discovers new ways to surprise itself with the infinite creativity of existence. As we drift deeper into these final contemplations of cosmic mystery, we encounter something remarkable happening within the very process of our exploration. The act of consciousness investigating reality creates patterns that seem to mirror the phenomena we've been discussing, as if the universe delights in these moments of self-recognition through minds like yours. Consider how the recursive nature of consciousness studying consciousness reflects the self-referential loops we find throughout physics. Just as quantum systems can become entangled with their measurement apparatus, blurring the boundary between observer and observed, your awareness right now is simultaneously the tool of investigation and the phenomenon being explored. It's a beautiful example of the kind of strange loops that seem woven into the fabric of reality at every scale. This mirroring extends beyond individual consciousness to the collective human enterprise of understanding the cosmos. Every generation of scientists and philosophers builds upon the insights of previous generations, creating an ever-expanding spiral of knowledge that somehow manages to reveal new mysteries faster than it solves old ones. We are part of a living tradition of cosmic inquiry that stretches back to the first humans who looked up at the stars and wondered what they were. Take a moment to feel your place in this vast chain of curiosity. The same sense of wonder that moves through your thoughts right now has motivated countless minds throughout history, from ancient astronomers tracking planetary motions to modern physicists probing the quantum realm. You carry within yourself the entire heritage of human questioning, the accumulated legacy of beings who refused to accept the world as merely given, but insisted on understanding how and why it works. The breakdown occurs when we try to separate the process of understanding from the reality being understood. Perhaps they are not two different things, but aspects of a single cosmic phenomenon, the universe developing the capacity to comprehend itself through the emergence of conscious observers embedded within its own structure. In these final moments of our journey together, something beautiful happens when deep understanding meets genuine appreciation. The cosmic mysteries we've explored tonight don't just satisfy intellectual curiosity, but can awaken something that feels very much like love. Not romantic affection, but a profound sense of connection and care for the reality that encompasses and creates us. This isn't mystical thinking, but a natural response to recognizing our intimate participation in something so much larger and more creative than our individual lives. When you truly grasp that the iron in your blood was forged in the heart of a dying star, that the calcium in your bones was created in stellar explosions billions of years ago, and that the very space between your atoms seethes with quantum activity, how can this knowledge fail to evoke a sense of wonder and gratitude? The universe spent nearly 14 billion years preparing the conditions that make your existence possible. Every symmetry breaking, every phase transition, every moment of cosmic evolution contributed to the emergence of chemistry, biology, and eventually the complex neural networks that allow you to contemplate these very processes. You are not an accidental byproduct of cosmic evolution, but its temporary flowering into self-awareness. This perspective doesn't require abandoning scientific rigor or embracing supernatural beliefs. It simply invites us to recognize that understanding and appreciation are not separate activities, but different aspects of the same fundamental relationship between consciousness and cosmos. When we truly understand something deeply, we naturally begin to care about it. As you sit quietly with these ideas, notice how intellectual understanding can transform into something warmer and more personal. The abstract physics we've discussed tonight becomes intimate when you recognize it, flowing through your own existence, creating the very thoughts and feelings through which you engage with cosmic mystery. This transformation from knowledge to appreciation might itself represent a fundamental feature of how consciousness relates to reality. Perhaps the capacity to move from understanding to love, from analysis to wonder, from separation to connection, is one of the most remarkable abilities that the universe has developed through minds like yours. As our gentle exploration draws toward its natural resting place, we find ourselves in what might be imagined as a cosmic library, where every answer we've discovered tonight sits on shelves surrounded by countless volumes of questions yet to be explored. This isn't a limitation, but the most wonderful feature of reality, its inexhaustible capacity to reward curiosity with ever deeper mysteries. Each territory we've visited, from the breakdown of physics in black hole singularities to the emergence of consciousness from quantum processes, represents just the opening chapter of vast stories that continue to unfold through the work of scientists, philosophers, and contemplatives around the world. The questions we've touched upon tonight will occupy human minds for generations to come, and likely will generate new questions we can't even imagine yet. This infinite quality of cosmic inquiry mirrors something beautiful about consciousness itself. No matter how much you learn, how deeply you understand, how profoundly you contemplate existence, there's always more to discover. The capacity for wonder appears to be inexhaustible, as if awareness itself participates in the same creative principles that generate endless cosmic complexity. Think of tonight's exploration not as a complete journey, but as a gentle invitation to remain curious about the reality that surrounds and creates you. The same processes that govern distant galaxies are operating within your own body at this very moment. The same quantum fields that perplex physicists in their laboratories extend through every cubic centimetre of the space around you. You don't need sophisticated instruments or advanced mathematics to participate in cosmic mystery. It flows through every breath you take, every heartbeat, every moment of conscious awareness. The universe is not something distant that you observe, but something intimate that you embody. Not something separate that you study, but something unified that you participate in through your very existence. Take a slow, deep breath and feel how this simple act connects you to the vast web of cosmic process. The oxygen entering your lungs was created by stellar fusion. The electromagnetic forces that bind the molecules in your blood operate according to the same principles that govern quasars and neutron stars, and the quantum processes in your neural networks mirror the fundamental creativity that drives cosmic evolution itself. In these final moments together, let's rest in a profound recognition that has emerged throughout our journey. The universe appears to have developed, through consciousness, the capacity not just to know itself, but to appreciate itself, to feel gratitude for its own creative unfolding. This appreciation flowing through your awareness right now might represent one of the most remarkable achievements in the entire cosmic story. Consider the extraordinary fact that matter has organized itself into patterns complex enough to experience wonder at the very processes that created them. You are the cosmos temporarily folded into a form capable of awe, gratitude, and the kind of contemplative appreciation we've shared tonight. Through your consciousness, the universe gains the ability to value its own existence, to find meaning in its own creative expressions. This capacity for appreciation doesn't diminish the profound mysteries we've explored, but adds another layer of depth to them. Not only does reality exhibit incredible creativity in generating black holes, quantum phenomena, and emergent complexity, but it has also managed to create observers capable of recognizing and celebrating that creativity. When you feel moved by the beauty of a sunset, you're participating in the universe's appreciation of its own electromagnetic processes. When you experience wonder at cosmic mysteries, the cosmos is experiencing wonder at itself. When you sense connection with something larger than your individual existence, that sensing represents reality, recognizing its own unified nature through the temporary lens of individual consciousness. This doesn't mean that individual awareness is unimportant or that personal experience lacks significance. Rather, it suggests that the preciousness of individual consciousness lies partly in its role as a vehicle through which the universe can know and appreciate itself. Your unique perspective, your particular way of engaging with reality, contributes something irreplaceable to the cosmic process of self-discovery. As you prepare to return from this contemplative space to whatever activities await you, carry with you not just information about cosmic phenomena, but this deeper sense of participation in something magnificent and ongoing. The questions we've explored together will continue unfolding through your thoughts and dreams, through conversations with others, through quiet moments when wonder spontaneously arises. As we reach what might seem like the conclusion of tonight's journey, we discover something beautiful about the nature of authentic exploration. There are no true endings in the realm of cosmic mystery, only pauses in an eternal dance between consciousness and cosmos, between wonder and understanding, between the known and the unknown. Every question we've contemplated tonight opens onto landscapes of further inquiry that stretch toward infinite horizons. The breakdown of physics in extreme environments that we've explored reveals not the limits of reality, but glimpses of deeper mysteries that call us to greater wonder and discovery. We've travelled together through the most mysterious territories where physics dissolves into wonder, from the infinite curvature of black hole hearts to the quantum foam that bubbles beneath reality's surface. We've witnessed matter forgetting how to behave in neutron stars, watched time bend into impossible loops, and contemplated the profound breakdown that occurs when the universe becomes conscious of itself through minds like yours. Why? Perhaps the most beautiful discovery of our journey is this: the places where physics breaks down aren't failures of understanding, but doorways into deeper appreciation of reality's inexhaustible creativity. Every boundary we've encountered, from the event horizons that hide cosmic secrets to the measurement problems that blur the line between observer and observed, reveals a universe far more mysterious and interconnected than our everyday experience suggests. You're not separate from these cosmic phenomena, but woven into the same fabric that creates quantum entanglement and dark energy. The breakdown of physics in extreme environments mirrors the beautiful breakdown that occurs when matter organizes itself into patterns complex enough to contemplate its own existence. In your wonder at these mysteries, the cosmos experiences wonder at itself. Tonight, as you rest, remember that you carry within yourself the same creative principles that shatter symmetries, birth galaxies, and somehow transform unconscious processes into the miracle of conscious awareness. The universe dreams through you, and in that dreaming discovers ever new ways to surprise itself with the depths of its own possibility. Sweet dreams, fellow travellers. The infinite mystery continues its eternal dance, and you are part of that dance, forever exploring the beautiful breakdown where the known dissolves into wonder, and wonder opens onto infinite discovery. And wonder opens onto infinite discovery.